Today we're here to talk to you about hybrid search and advanced retrievers in Data Cloud. And I hope you have memorized this slide. This is our love letter to you. So please make your purchasing decisions based on existing product features, as we are a publicly traded company. So thank you for being here. We know you could have been in a lot of different places, but you choose to be here, so thank you. And so my name is Franny Shao. I'm a distinguished AI architect at Salesforce. And joining me today are Anoop and Paolo. Anoop is a senior manager of engineering, and Paolo is a senior director of product, both from Salesforce. So today we're going to start with a real-world scenario highlighting a customer pain point. So I live in Ireland. And recently, in January, we were hit by a storm called Owen, if you're wondering how to say that. And this was a massive storm that caused widespread damage, and a lot of people were without power or electricity, right? And prior to the storm, they were calling their insurance companies to ask about their home insurance coverage. And this was a really straightforward use case for vector search. Right, leveraging semantic similarity to identify the relevant text in your policy documents to answer users' questions. Now, when it comes to the specific storm Owen, this is where keyword search could be really helpful. But in addition to your regular home insurance coverage, there is an additional assistance scheme. Hopefully you can see, oops, didn't mean to do that. You can see this humanitarian assistance scheme has, right? So these are things where vector search is not terribly good at because there's no meaning to it. It's HAS, it's an acronym, right? And it's Owen, it's a name. So this is where keyword search really shines. Now, if you notice on the bottom of that screen, right? Prior to the storm, the Irish government published additional updates to help people manage the storm situation. So normally there's a means test to be eligible for HAS, but they waived that for stage 1 applications. This information, because it was published on the 31st of January, it wasn't available in previous versions of the policy document. And that's important, and we'll see why. So now the user query you see on the left-hand side, right, is a true user query. So somebody will be calling up their insurance company saying that I have been affected by Storm Owen. I submitted a claim under HAS, and I believe I'm at stage 1. I need to understand, do I need to do this, go through this means test? Also, what is my coverage? And where can I get more information? If you remember, right, there was this addition that was added by the government, and this is where all the relevant information is located. So now what we want to show you is actually think about the different scenarios, right? So vector search is great at finding semantically similar documents, but keyword search, when you have policy numbers, HAS, and specific storm names like Owen, keyword search gives you better results. But now, if you just index everything without optimizing for recency, because we know there's additional information that was added at the end of January. So if you treated them all as equally, you're not going to get the best result. And this is where ranking factors come in. And we'll give you a demo now. Almost tripped over that. So this is Prompt Builder. And if you haven't played with this, we encourage you to go to Setup. This is where you build reusable prompt templates. And on the screen here, I have 2 identical prompts, right? So you can see they're exactly the same in terms of the prompt we're sending to a large language model. The only difference is what you see in the middle here. This is the retriever, right? And a retriever, this is the no-code retriever, which means you just basically configure in Data Cloud and you don't have to write any code. It's a game changer. And this is how you're able to retrieve the relevant information. The difference between these 2 prompts is that the first prompt pretty much indexes everything equally, whereas the second prompt is optimized for recency. So the more recent information will surface as the top chunk. So now if you remember the query, this is where you saw on the slide previously, right? This is the user question. And so if you look at just the query and the retriever without optimizing for recency, you can see that the large language model was very helpful. It followed the prompt, right? It gave helpful information, and it showed empathy. But you notice that it was still providing information about means test, because that was an older policy of HAS, or HAS, right? And this is why you can see this is the top chunk that does actually not contain the most recent information that was added to the website that we took you through. On the other hand, if we're looking at a retriever that's actually optimized for recency, with the same query, you can see that this time, the answer is clearly leveraging the latest information and says there's no means test requirement here, right? And now I want to just quickly show you how easy you could actually add a retriever to your prompt template, right? So there's the resource picker here, and again, you're not writing any code. You simply select the retriever you want from this drop-down menu. You go to Einstein Search, and all of your retrievers are here. And note that a default retriever is automatically created for you when you create a search index. And so this is really how you start to see the power of leveraging these ranking factors. And now I want to invite Anoop to the stage, right, to really kind of go into deeper detail about these ranking factors. I showed recency, but there's more, right? And there's also rankers that he will talk about. So without further ado, Anoop.
Thank you, Franny, and hello, everyone. I'm Anoop, an engineering manager on Search Relevance Vertical at Salesforce. Now that you have seen how prompt builder and retrievers can help your RAG flows there, let's go deep into the engine behind these tools, the hybrid search. We'll explore how to fine-tune the system boosting ranking across 4 key dimensions: the semantic similarity, lexical or keyword relevance, popularity, and recency. By optimizing these factors, we can significantly improve search accuracy and deliver more dependable, context-aware search experience for our users. Now, let me show you how can we play with these configurations. So I'm on Query Editor. This is a playground provided by Salesforce for you to tune your queries and also perform some ad hoc queries. And what I'm doing here is I'm playing with the 3 tables here. 1, the index DMO, 2, the chunk DMO, and the 3rd one is the source DMO here. And if you see what I'm passing on line number 4 here is the query. On line number 5 is the pre-filter expression. So if you want to basically like filter something specific to your use case, so let's say, right, like your retriever is configured for a home insurance policy. You don't want to surface something like a car insurance document or car insurance policies there, right? So that's where you can pre-configure your pre-filters. This will help you basically like filter out the irrelevant result at first stage. Now, this is like the most interesting part, the ranking function. So today, we support 3 ranking functions. One is RRF, reciprocal rank fusion. The other one is deep fusion ranker, which is DFR, and linear fusion ranker, which we call LFR here. So Paolo will talk about them in more details, but here, for simplicity's sake, I'm covering the RRF here. So let's look into like a few queries here. How many of you think a rider means a commuter, passenger, or basically like a driver there? In insurance industry, rider means addendum. And when you are basically like talking about rider, you don't want to see results which are more on the car insurance side, which is happening here because what I'm doing is I'm putting a lower weight on keywords. So that means I'm putting a very high weight on the semantic similarity here. So if I'm putting 0.1 for keyword weight, it automatically detects that like there is 0.9 weight for the semantic similarity there. And this weight ranges from 0 to 1 here. So if I have to find the right chunk or right document at the right position, for the domain-specific queries, what I'll do, I'll tune the ranking parameter for the keyword weight a bit higher. And what you'll see here is another article coming up on top. And let me make some space here. And I'll show you what it has. So this has something like consider adding a rider for water backup coverage. So this is trying to find the exact match here. And this is what basically like the keyword boost can get you. Now switching into the recency factor there, if you see here, I have 2 articles pre-filtered here because I just want to focus on the HAS-related policies there, right? So what I have is a policy which was updated somewhere in 2022, and there was a second revision to that in 2025. But what I'm seeing on top, because I have put 0 weight on the recency, we are seeing a policy which was older coming on top. Now, if I want to fine-tune this number to basically like put the right document on top, I'll just add a little bit boost into the basically like the recency weight there. So what I'm doing is I'm adding a very small number because I don't want to overpower my keyword or the semantic similarity weights there. So that's where like we have to play very small and keep on tuning it as we go and we find the optimal result. By default, what result you get, we have some default configuration in place. So if you are not putting these weights, we are hoping that this will work. But if it doesn't work for your configuration, you can just tune it a little bit here. So if I do it with a little weight, you're seeing that the recent article is coming on top. Now, let me go into the basically like popularity. So what I have configured here is page views as the field for popularity. And like the previous use case, you are seeing something with lower page views coming higher, because what I have is popularity weight set as 0. Now, if I want to tune this further, and let's say, right, like I put 0.009 as a weight here and run this query, what I'm seeing is the query with higher page views is coming in front. OK, with this, I'll conclude my demo, and I'll pass it on to Paulo, who will talk about the key takeaways from this session. Thank you, everyone.
Thank you, Anup. Hello, everyone. I'm Paulo Gomez. I'm a product manager for search in Data Cloud, and I'd like to wrap up this session with basically 2 main things. Do an highlight and an overview of hybrid search, and then talk about what are the options that you have for configuring the ranking of hybrid search. So let me start with why grounding. So grounding is the process of getting information, the relevant information, into the prompt so that the LLM or the AI model can generate an answer with the most relevant information and with the most up-to-date information, so that you basically diminish as much as possible the hallucinations of the AI model. That's the major advantage that you have in using grounding. The second one, which is also very important, is that grounding enables citation, because the LLM can trace back to the information that was used to generate the answer. So besides the answer that goes to the user, it also goes some blue links that the user can click and inspect if the information in the sources backs up the answer. So it's very important to instill trust into the users. The last advantage that I would like to call out is that with grounding, because you're giving the latest information and also the most relevant, you don't need to retrain the LLM model, which is a costly operation. So as you know, hybrid search is one of the main ways to ground in the Salesforce platform and in Data Cloud. And I'd like to talk a little bit about it using this query example that you see here in the slide. So am I covered in case of Storm Owen? And here, vector search, which is one of the main components of hybrid search, is very good at understanding the meaning of these words. So we can understand that you're talking about coverage, that you're talking about a storm. But one of the limitations of semantic search or vector search is that specific domain terms that the models that semantic search uses were not trained on, it will introduce some kind of noise. So basically, semantic search will not know what is on there, that specific word. That happens with other words like AJS, product names, and other acronyms. So it's very important to bring keyword search into the mix. And that's the second main component of hybrid search. So keyword search is very good at doing exact match, at finding the documents or the information that has the words that you're looking for. So it's able to retrieve the right documents and influence the ranking in bubbling up the information, in this case with Ian on the text. So hybrid search gets you the best of both worlds. The capability of understanding meaning of words from semantic search and the capability to deal with specific domain vocabulary from keyword search. How do you use it? 3 main steps to use hybrid search. First one is you have to have your information into Data Cloud, into a DMO or UDMO. That's the first step. Second step is to create a search index. And when you create a search index, there are 2 main operations that are going to happen. The first one is that the search index is going to take all the information that you have in the DMO that you want to search for and break it into pieces of text that we call chunks. Then those chunks go into 2 different pathways. First pathway is through what we call the vector embeddings, where we transform each chunk of text into a vector of numbers. And that vector of numbers is very important because it holds the representation, the semantic representation of that text. It's the meaning of the text that is fundamental for vector search to work. The other pathway is the chunk is going directly to be stored in the keyword search index. So in the vector search index, you store the vectors. In the keyword search index, you store the text itself. Then the last step, the third step to use hybrid search is basically what Anup showed. When you issue a query, it goes into hybrid search, but it goes first to what we call the hybrid fusion ranker, which is a module that basically is going to send the query both to vector search and to keyword search, get its results, merge them, and re-rank them using ranking functions, okay? And the ranking functions are very important, as I will highlight in the next slide. So this slide is about how do you optimize hybrid search. You've seen already, Anup and Franny already talked about it, but I'd like to give you a better view, an overview of what we have. And we have 2 main dimensions that you can use to optimize hybrid search. You have the ranking functions, and those first 3 boxes that you have on the left are the possibilities that you have today. So reciprocal ranking function, linear fusion ranker, and deep fusion ranker. But you also have the ranking factors. Let me start with the ranking functions. So there's 3 possibilities available today that you have to select. Reciprocal ranking function that Anup showed, a simple function that you basically have 1 parameter, which is how important do you have vector search versus keyword search. So if you go more to 0, you go more to vector search. If you go more to 1, you go more to keyword search, okay? Simple to use, but limited in terms of potential. Then we have the linear fusion ranker. That function is more powerful. It has more parameters. It has the same parameter as RRF, but it adds other parameters. So we are giving you more control on how to specify the ranking function, okay? Again, more complexity, more control, and you need a deep level of understanding there, okay? The third one, which we call the deep fusion ranker, it's basically a deep learning model that we teach on how to learn how to rank the results. So it's a kind of black boxes. It doesn't have parameters, but from our experimentation, we saw better results than the linear fusion ranker or the RRF, And we saw also that it generalizes better to new domains. So it's clearly something for you to test and to take into account. The last thing that I'd like to highlight here is the ranking factors that Anoop and Franny already talked about, the popularity and the recency. So basically, popularity, you want the results that are usually more recent to go up, and the recent ones also to go up. And you can do this by, when you create the search index in the advanced mode, you can set up the popularity and match it to a field. In the case of popularity, you can use a field that has the views or the votes. In the case of recency, you can use the last modified date or the created date, depending on what you want to do. Just to wrap up this presentation, I'd like to do just a brief overview of what we currently have in terms of features for hybrid search. So several pre-filtering and post-filtering options. We also have the two setup modes, easy or advanced, the configuration options that I just mentioned, and multi-language support. Coming soon, we'll be taking these ranking configurations to the retriever so that you can specify and select the ranking function without any code, so directly in retriever, and also new rankers, like the cross-entity ranker. And with this, I conclude our presentation. Thank you, everyone. I hope that this has been useful. Thank you.